Okay. Where are we? Sir. Okay, guys, we'll start. Um, Network and host portion. Network and host part. See, yours is 14th batch, right? So I'm giving roll numbers for you. Okay. Roll number 1, roll number 2, roll number 3, roll number 4, like this. Roll number 6, roll number 7, like this. And I have another batch also there. Also I given roll numbers for that one. Roll number 2, roll number 3, roll number 4, roll number 5, roll number 6, like this. Okay. But how to identify? This belongs to 14th and this is belongs to 13th. Then I'm adding like this. 14, like this. So I can identify these people with this roll number 1407 or 1404 belongs to 14th batch. Okay. And for 13th batch, I put it like this. So then I can identify these members belongs to 13th batch. Okay. So for that is called a uniquely identifying. So each individual person having their own roll number, but commonly they are having a batch number. So this is part representation of network. This part is like a representation of host. Okay. You have a systems in the network. Okay. You have a systems in the network and you are assigning IP address. Again, this IP address are having network and host part. The network part, for example, this is the network part. One is a network part. Think like this. So these are all belongs to same network. And this is host part. Host part is, for example, this is host is 1, host is 2, host is 3, host is 4, 5 is another. Okay. Totally, I have 5 hosts, right? Okay. These are the host part. Means it is a different from one system to another system. A network part, which is same for all the system in the same logical network. Same logic. For example, I have another host. Okay, another host. It is 2.6. Okay, host is 6, but network is 2. It's a different network. Even physically it is connected, but it is a different logical network. If network portion is different from other systems, it's a different network. It belongs to different logical network. So obviously these 5 systems will communicate each other, but this system won't communicate it to this 5 systems because logically separate network. Physically, maybe it is, if you are connected physically, so physically same network, but logically separate network. That's it. So IP address is a logical address. Okay. Guys, understand network and host portion importance? We have a classes, class A, class B, class C, class C, because we are using only this thing. Class A is ranging from 1 to 127. Of course, we are not using total. We are using from 1 to 126 only. Okay. Class B is 128 to 191, 192 to 223. Okay. Class A, any IP address is 4 parts. But in an example, I showed only 2 part-wise, network and host part-wise. So in a class A or class B or class C, IP address means 4 parts. The first part means first octet is network by default. Default one is by default. The first octet is network by default. And the remaining octets are host representation. Similarly, class B. In a class B IP address, the first 2 octets are network, remaining 2 octets are host representation, host portion. Class C, first 3 portions are network portion, and the last portion is host portion. Okay, last portion is host portion. Okay, by default portion it is. But we can see simple an IP address. So what is the network portion and host portion also we can able to see. So 1 second. చెప్పండి. నేను ప్రస్తుతం ఇంటి దగ్గర లేనండి. నేను ఆఫీస్‌లో ఉన్నానండి. నేను వచ్చేసరికి 6:30, 7 అవుతుంది. మేబీ 6కి వస్తారండి. మార్నింగ్ మేము 9కి బయలుదేరిపోతాం. మీరు 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 ప్రస్తుతం దగ్గరలో ఉన్నారా? ఓకే. ఒకసారి ఒకసారి చెప్పండి. 5F వాచ్‌మెన్‌కి చెప్పండి. నెట్ రావట్లేదని ఒకసారి మరి కేబుల్ మీకు అర్థమవుతది కదా! ఇది ఇంటర్నల్‌గా ఇష్యూ ఉండదు మరి బయటేమో. హ్మ్. ఒకసారి బయట నుంచి చూడండి. లేదు అంటే మరి నాకు ఒక హాఫ్ అన్ అవర్, 40 మినిట్స్ పడుతుంది. ఇంకా అయ్యప్ప సొసైటీ నుంచి చూసాం. Okay, sorry guys. Internet problem in home. No one is there at home. So where are we? There is a Kaushik asked one question. Can they ask question related sub? No, no, not required to be like a subnetting. That much you no need to go. Okay, subnetting that much not. I just specified only what is subnetting one line and some example. That's it. So no need to learn deep about any subnetting part. Subnet mask is enough. Okay. So no need of subnetting. If anyone asks question related to subnetting, we can give that statement. That's it. Nothing more. Okay. Calculations and all not much required. So let's say no. So basics are very important. Too many calculation not required. Again, if I want if I want to teach subnetting, again you have to take at least 2-3 days. Okay. That's the point. Yeah. Yeah. Where are we, guys? Yeah. By default, if you see any IP address, too easy to identify what is network and host person, first identify its class, okay? And then we can understand based on that. If it is a class A, the first portion is network portion, remaining host portion. Class B, first two portions are network, remaining is host portion. For class C, first three are network portion, remaining is host portion. Next, the rule is if two devices or two or more devices want to communicate each other, their network portion must be same. Entire network portion must be same. Host portion is different. Either one host portion or entire host portion can be different. Okay. One host portion or entire host portion is different. But network portion must be same for all the devices in the network. In the same logical network means all their network portion must be same. This is the rule. Okay. Next, next, we can understand by this simple, this is the network portion, this is the host portion kind of stuff. But how system will understand what is the network portion, what is the host portion? It is based on the subnet mask. What is the subnet mask? System use this subnet mask to differentiate the IP address. What is the network and what is the host portion? Which is which portion is network portion, which portion is host portion, and also tell the network ID. But it will tell the network ID. So here was some example. You see, I have an IP address. For example, it is 151.34.4.5. Okay, it is an IP address. 151 means it is class B IP address, right? So this is my PC1 system. IP address is 151.34.4.5. And again, I configure a PC2 151.34.4.6. PC3, I'm configuring 151.34. Um, 1 second. Okay, here it is. Okay, sorry. Okay, see it is. I have a three systems and configured a IP address. And it is a class B IP address, right? The class B first two portions are network, remaining is host portion. See, for this PC and this PC and this PC, their network portion is same. And host portion, here too, if you compare this one host portion is different, but other portion is same. Here, both host portions are compared to this, both portions are different, but still they are in the same logical network. So all these three pieces will communicate each other because there are logically same network. Either one or multiple host portions can be different, no problem. For example, I have a PC4. The PC4 IP address is entered like this, like for that is 7. Okay. And I have a PC5 system is also there. That is, if you look at this, if you look at this is, okay, so it is different from PC1, PC2, PC3. So 35 I entered. First is 151 is good, same, but second is 35. So different. Second octet is different. So network portion is different. So this system cannot communicate it to these three systems. Again, PC5, you go to PC5. So this is different from other systems. So PC5 also not able to communicate. Think like you have a 5 systems and PC1, PC2, PC3 are communicating each other. PC4 and PC5 unable to communicate to PC1, PC2, PC3 and PC4, PC5, PC4 to PC5 also not communicating. This is the issue, you got it. In your network, you are a network administrator, you see in the 5 systems. All are configured manually. Now what happened? Now what happened? Next, okay. So you first, what is this? Any network issues, how to resolve it? First, we'll check the physical connectivity. Physically, the connection is there or not, right? And physically, okay, physical connectivity is good. Next is you check the IP address. Then you found this PC4, PC5 wrongly configured, not configured properly, wrong configuration, right? It can be typo mistake. We will configure lot of devices by mistake also. We'll do it without seeing properly or without checking properly. Instead of 34, in PC4 you put a 35. In a PC5, instead of 151, you put a 152. By the mistake, this mistake is happened. Then what to do? Then what to do? Okay. Then what to do? You have to change it back to the actual configuration. You done a mistake of configuration and now it is not working. Then you have to change back. We have to change properly to the actual system. When you are changing also you have to check no two systems have same to same IP address. Means network and host version both are same to same with other system. It generate conflict. For example, I have a PC6 and in a PC6 I am configuring 151, 34, 4.6. So what happened? Between PC2 and PC6, conflict, IP conflict is generated. Now, this PC2 and PC6 cannot communicate it to others. What happened? They won't communicate to anyone, not to each other, not to anyone. PC2 and PC6. Why? IP conflict, because same network, same host version conflict is there. Now you found this one. This is called IP conflict. PC2. IP conflict, spelling mistake, IP conflict to PC2. So now don't worry. So what we have to do? We have to change the IP address. We have to verify IP conflict is came. Then we go to the change of IP address. Thumbnail. Okay. So or maybe untaken. So you have to change the host part. Network part is same anyway, but host part, some number you are changing, conflict will be resolved. Even that as also should not be conflict with others. The two troubleshooting also I told guys. One is if IP address not communicating, check the IP address, check the physical connectivity. If IP address not configured properly, wrong configuration, change the IP address configuration. Second one is IP conflicts. If both systems are having same IP address, both network and host version is same, then change the host version of one of the system, conflict will be reduced. Okay. So this is one point. Okay. Where are we? Someone put one more question. Very good. Very good. Anyway, guys, this is one good point. It is. So this is I came to up to the subnet mask. Right? These are the default subnet masks. These are the default subnet masks. So system use this default subnet mask to find a number of what is the host portion, what is the network portion. Also, you will get a network ID. Also, you will get a network ID. So, like I given some examples. You can read it. These examples also you will understand. So, what is this network and host portion issues? System divide network and host portions and how it will find network ID. So, using subnet mask. System use subnet mask to divide IP address into network and host portions and tell the network ID of IP address. And here also I written a rules. It is if devices want to communicate in the network, their network portion must be same, host portion can be different. Devices in same network can communicate each other, means the network portion is same. Devices in the same network means their network ID is same or network portion is same. The entire host portion should not be same. Okay, in the same network, at least one of the host portion must be different. What is that meaning? So here we put this 4.6 and 4.6 same. Should not be like that. Same to same IP should not be there. So at least one of the host portion is different. So then it will be acceptable. Or all host portions are at least one of the host portion. Okay. All host portions mismatching is not required. So at least one host portion is different from other systems. Okay. So it is good. Okay. Host portion for identifying system. Okay. These are all in the same network. This is a 151.34 network. We call that is 151.34 network. Network, but host, it is 4.5 host, 4.6 host, 8.9 host, 4.7 host, 4.9 host, 4.8 host, like that. That's a host identification. And how this system use this subnet mask to find network ID, network portion, and host portion, it use AND gate operation. If you see, this is an IP address and subnet mask. We convert into the binary and you you done AND between this, AND, logical AND between these two numbers, and you will get a network ID. You see, this is 1, 1. Okay, 1, 1, you will get 1 only. If you have a 0, 0, 0, 1, 1, 0, okay, you will get 0 only. So in that wise, 0, 0, so 0, 1, you will get 0, 1, 1, 1, 1, 1, 1. Okay, like that, you got this network ID. So this is a network ID of this system kind of stuff. For this is a network ID. For this IPC, it is 183.15.33.44. Another system 183.15.22.6. Okay. See, both are different IP addresses. And this is their subnet mask, class B subnet mask. Okay. Is these two systems will communicate each other not? Check their network IDs. Both are having same network ID, means they will communicate each other. Okay. So like this is based on their network ID. Okay, this is about subnet mask. Okay, what is the subnetting? Subnetting is dividing one network into multiple network subnets. Dividing one network into multiple subnets. This is one network. You divide this network into multiple subnets. In each subnets, number of hosts per subnet will be reduces. Okay, how do you doing subnetting? Subnetting will be do it by changing of subnet mask. How to change the subnet mask? Again, subnetting calculations are there. Using that calculations, we change the subnet mask automatically. Network and host portions are changes. See earlier, this IP address having two host portions based on the class B. Now, what is the host portion is only one. It's entirely network. See, their network ID is changed because subnet mask is changed. Now, these two systems won't be communicate just because of I change the subnet mask. So, why we need to do this subnet mask? Okay, why we require to change the subnet mask? Guys, you see, it's a class C IP address. This is an example of a class C IP address. The starting IP address is like this. This is the entire network portion, first three, 192.168.1.0. This is called a network ID. Okay. So why it is called network ID and why can't we assign to any device? Why? Because you see this is a host portion. This entire host portion is 0. So we can't assign to any host. Next number is 1. So this is the network part and this is the 1. Now this is the first valid host number. Then 2, then 3, then 4. We reach up to 254. Then it is 255. In a 255, this entire host portion is all are ones. So this is, we'll take it as a broadcast ID. After this, the network is changed. See? This is 1 dot, this is 2.0. Okay. This is 1, this is 2. Class C, this is entire network is changed. This is another network. So before 255, see 254, up to here we can assign. We can assign IP address to devices from 1 to 254. Not a 0, not a 255 here. This entire is, how many IP addresses are there? Up to here is 256. Minus 2, 0 and 255. So minus 2, 254 devices. Like in your network, you have a 254 device, up to 254 devices. So you can use a class C IP address. You have a 10 devices, go for class C. 50 devices, go for class C. 100 devices, go for class C. Okay. If you have a 500 devices, go for B, class B, because class B in one single network, you are getting 65,534 IP addresses. Okay, host IP addresses you are getting. From class C, you are getting only 254. Small networks, class C. Bigger than 254 means higher than 254, more than 250 devices you are having, then you go for class B IP address because you are getting 65,000 IP addresses, around 65,534 IP addresses you are getting. In case you are having very, very big network, more than 65,000 number of devices are there, you want to connect, all are in the same logical network, then you go for class C because class C will provide 16 millions of IP addresses. 16 million IP addresses we are getting. 16 million 777,000 4 number of devices we can able to connect it. Okay. So this is about your IP address, classes, subnet mask, kind of stuff. And why we need a subnetting? I said subnetting is dividing one network into some subnets. Guys, organizations required public IP addresses to put their servers into the public. We are accessing google.com, facebook.com, youtube.com, different websites we are accessing. So they need a public IP address. But you need 10 public IP addresses. You see, this is 250 for one network. Okay, least to least, class C will take it. But you are getting 250 for IP addresses. But how many you need it? 10 IP addresses. What is the remaining IP address? What about remaining IP address? Remaining 244 IP addresses. We are not utilizing, but we are paying. So what is this ISPs will do? They divide this one network into multiple. So around 14 IP addresses, we will get it in the division. We need a 10, but we are getting 14. Okay, instead of 244 IP addresses wasting, my wastage is only 4 now. Okay, so that is a division. Why we are dividing the network? To reduce number of hosts, because in the public network we don't require 200, 250 for IP addresses generally, because we have a limited number of devices in the public communication. Okay, so this is our IPv4 address. Okay. Of course, this part also there. This is called as slash notations. You try to read it. We'll see that one. And we have a private IP, public IP address also there. What to do? So I will complete this private IP and public IP now. Okay, that's it for today. Then we'll see how to assign an IP addresses. Okay, and IPv6 address and remaining OSA model and all we'll see tomorrow. Okay. So what is this private IP? Just now only I told no. Subnetting mainly purpose is when organizations use public IP addresses. They need multiple public IP addresses to make their servers to communicate out from outside. Okay, but they have a only requirement is 50 devices to be connected to the public. But they buying a public network, they will give you 250 for. So remaining 200 we are not using, but we are paying. Yeah. Subnetting is helpful. As per my requirement, as per my organization requirement, they divide a network. They give around near to the 50 IP address. Of course, I will get around 62 IP addresses. I will get it. I don't get 50 exactly, but 62 total I will get it by the division. Okay. So we are use a word public, right? So what is this public? Private. Guys, you have your own LAN network or your intranet. You have a devices, you want to assign IP address. So this IANA I can provide a specific range of networks for your own private use purpose. From class A, 10 network is given. This entire 10 network means 10.0.0.0 to 10.255.255.255. This entire network, you can use it for your private use. Okay. From class B, 170.16.0.0 to 170.31.255.255. This entire range is belongs to private use. So for using of this private IP address, you no need to pay or register. Permissions not required. This is only private internal purpose only. Okay. So from class B, totally 16 networks are given. Class A only one network, 10 network. But in class B, 16 networks are given. 170.16, 170.17, 170.18, up to 170.31 is given. In case 170.32, it's public IP. 170.15, public IP. 171 public, 173 public. Okay. But 172.16, 172.17, 172.18, 172.31. This is totally 16 public IP addresses. 192, 168, 0.02, 192, 168.255.255. So total range of private IP addresses. Okay. From class C. Totally 256 networks are given. 190.168.0 network, 190.168.1 network, 190.168.2 network, up to 190.168.255 networks. Totally 256 networks are given. Okay. These private IP addresses non-routable in public. Routable in private, but not routable in public. Means with private IP, you can't access internet. You can't access internet. So we're going to see my IP address once more. Check it. Check your IP addresses also. What is my IP? 172.16. So it is a private IP. With this private IP, I can't access internet. So I want to access google.com, facebook.com, youtube.com. I need a public IP. Okay. But I have a private IP. Okay. So these are the private IP addresses and ranges. But when I checking my system, I'm having a private IP. I don't have public IP. To communicate in a public network, need a public IP. So what happened? So what happened? I am searching for something that is NAT. So recent batch, I don't want to write because, we got 14, now it is showing 7. Okay. So this is simple. This is my internal part. How to edit, how to write on this one. Okay. So no problem. Just I will open with a paintbrush or any other tool. Okay, I'll take a color. So guys, this is my own private network, my intranet. Okay. Now I have a web server also in my private network. Okay. I want to access yahoo.com, facebook.com, youtube.com like that. And also someone in the network want to access my web server for my websites. What to do? So there is a technique called a NAT technique, network address translation. Okay. In the organization, what they will do it, they use NAT techniques for to make communication between private to public network. So in the router, they what they do, they take the devices, private IP addresses and their public IP addresses. Okay. They map your private IP to public IP in the router. So when you are accessing, like this is 1.11, sending a request to the like a accessing youtube.com, for example, like this is want to reach youtube.com. Okay. So youtube.com, I typed it. So what happened? Request sent to the router. Router verifies it is 1.11 and it will convert this IP address. It send that request with a public IP to internet. From there it reaches youtube.com. youtube.com don't know your private IP. It knows your public IP. And it is sent that reply to your public IP. It reaches to your router. Again, it is retranslate back to the private IP. And you got the reply to your system. Okay, this is a NAT. It is one-to-one type, one private, one public type communication. Okay, internally it's a private, externally public IP addresses. Okay, here I have a something like a 1.20 is a private IP address to my web server. Someone want to access my web server from internet. So what they have to type my IP address, but this is private IP, non-routable in public, not available in public, right? So you can't reach with this one. So what they have to do, we are already binded this private IP to a public IP in our router. And we are told if anybody want to access my web server, use this public IP only. So they said like with this public IP, they try to reach to my router. Again, it translate to the private IP, send request to the web server. Web server provide that information. Okay. It is one-to-one mapping, guys, and internally private communication only. For example, from here, from this CPC, I'm accessing this website, I can use 1.20 only. With this private IP, I can communicate. But when I'm communicating from publicly or to public, I should communicate with the public IP address only. It is maps inside in the router only. Not in our system, it's in the router only. So this is what I said, NAT, network address translation. Okay. So why I'm telling one-to-one type? Because in your home or organization offices, how many private IP addresses are there? For every private IP address, you are buying a public IP, it's very cost. Public IP addresses, you have to pay. First, you have to register and get assigned with a public IP. Okay. And then you have to pay for use of public IP addresses. But you want to access your system from public or you want to access something in the public, you need a public IP address. Thing is, guys, in our home, we have a different public IP address. Right? So, sorry, we have a different private devices are there inside our network, like my system. For every device, if I want to buy a public IP, it's very costly. I have a 10 devices, then I need a 10 public IP address. So it is costly, lot of cost. And the thing is, I want to access youtube.com. I want to access facebook.com. I want to access gmail.com. I don't want to get access from anyone. Okay. I don't have any servers, or my system no need to be directly communicate from anyone through internet. Just I need to get connected, not from there. Okay. It's only from inside to outside, outside to inside, not outside to inside. Okay. So this is a technique called a PAT technique. This PAT technique also called as NAT overload. Here also we are using NAT only. Okay. Inside private to outside public. Here there is a NAT only. But thing is, in the NAT, every private has a one public IP. Here, all internal private IP address having one public IP address. See, these are all private IP addresses, and this is one public IP I'm using. With the help of port map technique, okay, so I can differentiate that one. So I don't need to buy 10 for 10 devices, 10 public IP address, not required here. And this public IP also take care by ISPs generally. Okay. So if you check all the IP systems, IP address are private IP inside. Like my system, it's a private IP only. If I go to Google and type what is my public IP, you'll find public IP. Just you send a request to the youtube.com. Okay. So when you are going outside, you go with the public IP only. And also it will map a, a port, internal port mapping is also happen. You send request, you reach you do google.com, facebook.com, youtube.com. They are also giving reply to your public IP only. Once it is comes, it verify the port and again retranslate to your local IP with your port, then it's sent to your system. This one knows your public IP and they don't know your private IP. Even though they know private IP also, they can't reach it. Now, even though they know your public IP also, they can't reach you. Why? Because same public IP is used for multiple systems. Okay. So, is it A system public IP or B system public? Not like that. Because these port numbers also not fixed port numbers. Dynamically assigning port numbers depends upon this time. So this is 1.11. This time it is 44411 port number. After some time again, it different port number. Okay, these port numbers will keep on changing. So it's a dynamic port number. This port number maintained till transaction completed. One transaction is completed, port numbers will be changed, removed. It won't be in this PAT technique. New request, new port number is assigned automatically. Depends upon your sessions, number of sessions you created. So different port numbers. Each session, different port number is created. Okay, like this. Just for example only. See different port numbers. See. Okay. I didn't access this one. Why I'm getting this? I don't know. So I open some website also try. So website, right? HTTPS. But here it is some random port. Destination, port, and this is our local port. Okay. Like public, we can't get it because I am in my system. If I enter into router, maybe I will get that information. Okay. So This is called a PAT, port address translation, also called as NAT overload. What is NAT? We are overloading on the single NAT. Okay. So NAT and PAT. To communicate from private to public, what we are using is NAT and PAT techniques. Okay. So even someone knows your private IP, public IP, MAC address, they can't reach your system directly. But how people can reach your system? How can able to track your system or utilize your system or maybe doing some things in your system? If you are open any illegal websites, tiny URLs, so some kind of banned means some VPNs you are using. Okay, some third party download applications. Okay, you download an application from original site, no problem. From third party sites you download. Torrent sites you are accessing. Okay, so what happened? They try to come to your system because you are welcoming them. You ask Google, come Google to your system, Google will come, genuine person. Just something googly.com. Okay, googly.com. Instead of Google, we went to googly.com. Maybe it's not a genuine. So you ask them to provide their page or picture or something. They put something inside and you click it. So they will enter into your system automatically. Okay. So that's the point, guys. NAT technique. So tomorrow, what we will do? First, we'll discuss about IPv6, IPv4 and IPv6 differences. Okay. How to assign IP address manually, automatically, and what is IP address also we'll see it. Okay. And we'll try also these things like OSA model protocols, troubleshooting using OSA model. We'll try max to complete. Otherwise, one more day. Okay. So be prepared, guys. Please go and relax first and then start preparing. I'm stopping here.